Hi everyone. In this video, we will explain a trigonometric ratio. So what is the trigonometric ratio? It's a ratio of two sides of the right triangle, So here, in the right triangle, if this is angle A, the opposite side is going to be side A. And this is angle B, the opposite side is going to be side B. And the right angle, it's C, so the opposite side, which is the hypotenuse, is going to be what? It's going to be C. So, this is angle A, here, this is side A. If this is angle B, this will be side B. If this is angle C, so the hypotenuse here is going to be what is the side C. So always, the sine of an angle is a ratio of the length of the leg of the opposite, the angle, to the length of the hypotenuse. So when we need to ask about, if here we take the angle A, so let's erase this one and concentrate about that one. So, here, so if I need to ask about, say, angle B, if I ask what is the ratio for the opposite side and the hypotenuse, opposite side here for angle B, it's going to be what? It's going to be the side B over C. So what is the ratio for angle A for the opposite sides and the hypotenuse? It's going to be side A over C. So the ratio for any angle for its opposite side over the hypotenuse, we're going to call it by the sine ratio. So the sine is equal sine, the angle is equal sine theta or sine x or sine any angle, always is equal the opposite over what? Over the hypotenuse. Now, let's say angle A. What is the adjacent side of angle A? It's side B. And the hypotenuse, it's C. So adjacent over hypotenuse, it's going to be what? It will be B over C. So this relation, adjacent over hypotenuse, we're going to call it by cosine. What about the angle B? Which one is the adjacent? Adjacent is A and the hypotenuse is C. So the adjacent over the hypotenuse, it's what? It's the cosine ratio. Now, the third one, the tangent or the tan. For tan A, the opposite side is A and the adjacent side is B. If we take the ratio for opposite over adjacent, we're going to call this relation by tan. So the sine is equal opposite over hypotenuse. Cosine is equal adjacent over the hypotenuse. Tan is going to be equal to opposite over adjacent. So these three relations, we're going to call them by trigonometric ratio for the right triangle. And as a small abbreviation to always memorize them, we can say it's so, ka, tawa. Sine is equal opposite over hypotenuse. Cosine is equal adjacent over hypotenuse. Tan is equal opposite over what? Opposite over adjacent. So let's see how we can solve now for this relation. Write the trigonometric ratio as a fraction and as a decimal rounded to the nearest tenth. So sine J, where is J? Here is J. So we said sine is equal opposite over hypotenuse. So here is J. Where is the opposite? This is the opposite. Which one is the hypotenuse? Hypotenuse is always, it's the longest side, which is opposite to the 90 degree. So this is, here's the hypotenuse. It's opposite to the 90. So sine J, it will be equal 60 over 61, then direct we can find it by decimal, which is approximately equal to 0.98. Now I need to find cosine J. Cosine, as we said, is adjacent over hypotenuse. So katawa. So here, cosine J, this is J. Cosine is the adjacent. So which one is the adjacent? Is 11. What is the hypotenuse? It's 61. So what is cosine J? Is equal to 11 over what? Over 61. This is cosine J. So cosine J must be equal adjacent over what? Over the hypotenuse, which is equal 11 over 61, which is equal to 0.18. What about tan? Tan K. Here is K. So tan is equal to what? Opposite over adjacent. This is the opposite. This is the adjacent. So tan K is equal to 11 over 60, which is equal to approximately 0.18. So always remember, so ka tawa. Sine equal opposite over hypotenuse. Okay. Sine equal opposite over hypotenuse. Cosine is equal adjacent over hypotenuse. Tan is equal what? Opposite over what? Over adjacent. Now write the trigonometric ratio, also here as a fraction and rounded. The same thing. Cosine A. We said cosine is adjacent over hypotenuse. So it's 24 over what? Over 25. Here, I need to find what? I need to find sine P. Sine P, this is P. So I need to find the sine. Opposite over hypotenuse. Opposite is equal 24. Hypotenuse is equal 25. So it's equal 24 over what? Over 25. Here, what do we need to find? Here we have to stand up a little bit. I need to find the length of BC. So, BC is unknown. I need to find the length of this side. What information I have in this question? First of all, this is a right triangle. I have the measure of angle B equal 15. X is what? Is adjacent of what? Of B. And I have the length of AC. AC is what for AB? Is opposite. So actually, what information we have here? I have the opposite and I have the adjacent. So since I have opposite and adjacent and the measure of the angle, so which relation we gonna use? So, ka tawa. So opposite over adjacent. So direct here, we're gonna use the relation of what? We will use the relation of tan. So tan is equal opposite over adjacent. So since I have the measure of the angle, so tan 15 must be equal to what? Must be equal to opposite over adjacent. So it's 10.2 over x. So now what do I have to do? I need to find the value of x. So we can do the cross multiplication. So 10.2 is equal x times tan 15. So over tan 15 over tan 15. So from where I can get the value of tan 15 to get the answer of x? So direct here from the calculator. So this is the sine, this is the cosine, and this is what? The tan. So I have 10.2 over what? Over tan 15. So the answer is going to be equal what's here? So the answer is equal to 4, approximately 4.5. So it's approximately equal to what? To 4.5. Okay. Here I need to find the length of QR. What information we have? This is a right triangle. This is the QR. I have the hypotenuse. I have this angle. What is x for this angle? Actually, x for this angle is what? is the opposite. So I have angle, I have opposite, and I have the hypotenuse. Angle, opposite, hypotenuse. So which relation, we're going to use? So angle, opposite, hypotenuse. Opposite, hypotenuse. So here direct, we're going to use the relation of what? Of sine. So we have to say that sine 63 is equal to opposite over the hypotenuse here. So direct, again, we can do cross multiplication or shift solve. So x is equal to 12.9 times sine 63. So sine 63, direct on the calculator to get the value of here that 12.9 times sine 63. To get the answer is approximately equal to what? Is approximately equal to 11.5. Find the length here. I need to find the length of FD. So let's see again here what information we have in this question. FD is what? FD is the hypotenuse here. I have angle, I have adjacent, I need to find the hypotenuse. So angle, adjacent, hypotenuse. So which relation? Sine, cosine, or tan? So of course it's adjacent hypotenuse, it's the cosine. So what do we have to say? That cosine 39 equal adjacent for the hypotenuse. So x times cosine 39 is equal to 20. So x is equal to 20 over, so it's equal to, here, 20 over cosine 39. So it's equal to what? It's approximately equal to 25.74. It's what is the value of the hypotenuse in this question. Here, the same. I need to find the length of what? Of DF. Let's go. DF, here again, is what? Is the hypotenuse. I have angle, opposite, hypotenuse. Angle, opposite, hypotenuse. So which relation here we're going to use? Here direct, we're going to use what? It's the sine. So sine 51, it must be equal to what? 17 over x. So again, direct, we can use like a cross multiplication or shift solve as you want. So x times sine 51 is equal to 17. So over sine 51 over sine 51. So x must be equal to 17 over sine 51. It's equal to what? It is equal to 21.87. It's the length of the hypotenuse here. Now, I need also here to find ST. It's all to the same. ST, where is ST? Here is ST. So I have angle. I need to find the adjacent. And I know what? I know the hypotenuse. So which relation here? Direct, adjacent, hypotenuse. So it's cosine. Cosine 42 is equal adjacent over the hypotenuse. So x is equal 9.5 times cosine what? Cosine 42. So direct here, it's 9.5 times cosine, 9.5 times cosine 42. So the answer is going to be equal to what? Here it's approximately equal to 7.0 6. Okay, now I need to find CB and AC. So let's start. Let's start with finding CB. So angle, adjacent, I need to find the opposite. So angle, adjacent, opposite. So which relation? Direct here, we're going to use tan. Tan 22, it's equal CB over 15. So CB is equal to what? 15 times tan 22. So CB is equal to 15 times tan what? 22. So the answer is going to be equal what here? 6.06. Okay, now we need to find the AC. So I have angle, I have adjacent, I need to find the hypotenuse. So here we can use what? We can use cosine. So cosine 22 is equal 15 over AC. So AC times cosine 22 is equal to 15, then over cosine 22 over cosine 22 to get the value of AC, 15 over cosine 22, 15 over cosine 22. So the answer is equal to what? So here AC is equal to 16.18 or 16.2. It depends to round to the nearest hundredth or to the nearest tenth. Okay. Now let's solve this problem. A steel cable supports an electrical tower as shown. The cable makes 65 angles with the ground. The base of the cable is 17 feet from the tower. So what is the height of the tower to the nearest foot? So what is the height? Here is the height. So actually here is the height with its shadows represent what? Represents a right triangle. So I have angle. I need to find the opposite. And I know what? I know the adjacent. So angle, opposite, adjacent. So direct tan 65 is equal opposite over adjacent. So H, it will be equal 17 times tan 65. So H is equal to 17 times tan 65. So the answer, it will be approximately to 36.5. It's the height for this point, for this steel. Okay, now if I have the value of the sine and cosine and tan or any of them, and I need to find the measure of the angle. So what do we have to do to find the measure of the angle if I know the sine or the cosine or the tan? So in this case, we will use sine inverse, cosine inverse, or tan inverse. To get them on the calculator, we have to do what? Shift sine. Suppose the value of the sine is equal half. So the angle is equal 30. Or shift cosine or shift tan. So if we know the value of the sine, cosine, or tan, so it's enough to do shift sine, shift cosine, shift tan to find the value of what? To find the value of the angle. Okay. Find the unknown measure here, the same, and then the sides and the length. Let's look at this triangle. I have the length here and this one. I need to find, first of all, ST. So to find ST, as we said, always in a right triangle, if I know the measure of two sides, I need to find the measure of the other third side. So the first thing you have to think about it is what is the Pythagorean theorem. So this is the hypotenuse, this is the leg, and this is the leg. So always remember that c squared is equal a squared plus what? Plus b squared. So here, to find the value of the side that I need to find, that 5.7 squared is equal to 5 squared plus b squared. So b squared, it will be 5.7 squared minus 5 squared under the square root. To find the measure of this side is equal to 2.74. So always in the right triangle, if I know the measure of two sides, I need to find the measure of the third side. So always remember that I can use the Pythagorean. Now what about the sides, the angles? I have no idea about the angles. Only I have angle, this angle is equal 90. So suppose I need to find the measure of angle R. What information about R, about the sides that relation to the R? That I know the adjacent and I know the hypotenuse. Since I know the adjacent and I know the hypotenuse, I can find the angle? Yes. By using what? Cosine inverse. So to find measure angle R, so we have to say cosine inverse 5 over 5.7. So direct here on the calculator. So cosine inverse that 5 over 5.7. It's equal to what? It's approximately equal to 29. So here this one is approximately equal to what? Is approximately equal to 29. So always remember, if I need to find the measure of the angle and I know any relation between any two sides in the right triangle, I can use cosine inverse, sine inverse, or tan inverse. Now I need to find the measure of angle T. So as we know, that the three angles in the triangle is equal to 180. So since I know this is 90, this is 29, so we can find the measure of angle T. So we can say that here 90 plus 29 plus x is equal to 180. To get the value of it is equal to what? Is equal to 61. Okay. Now, what do we need to find? Here, find the unknown measure, round length, and nearest hundredth, the same like the previous question. So what I need to find here? So I have the measure of this angle. I need to find the measure of angle D, and I need to find the measure of the two sides. Let's start with finding measure angle D because it's easy. As we know that the three angles in the triangle is equal to what? Is equal to 180. So since this is 90, this is 58. So direct, what we can say to find the measure of the angle, it's equal here what? We can say it's 90 minus 58. To get the measure of this angle is equal to what? 32. Now what about the sides? I can use the angle 58 or now I can use the angle 32 as you want. Any of them is correct. So let's start using 58 to find EF. So I have the opposite. I need to find the adjacent. So what relation we can use? Direct, we can use the relation of tan. So tan 58, it's equal 14 over EF. So now direct we can do as we did before, shift solve or cross multiplication to get the value of EF here is equal to what? 8.75. Now about the hypotenuse. I can use Pythagorean since now I have the relation of two sides, or I can use what? I can use cosine 32 or sine 32 or sine F or cosine F. Any of these 5 ways give me the same answer. So here we solve it by Pythagorean. So that the hypotenuse squared is equal 14 squared plus 8.70 squared. So under the square root, to get the answer of DF is equal to what? 16.51. Okay. Now, here, let's do the same for this triangle. Okay. So I need to find the measure of the unknown sides and the unknown angles. So first of all, write a triangle. I have the measure of two sides. I need to find the measure of the third side. So this is C. So C squared is equal to 2.1 squared plus 5.3 squared. So under the square root. So direct here that the answer is equal to 2.1 squared plus 5.3 squared. To get the final answer here is equal to what? Is equal to 5.7, or we can say approximately 6. Now I need to find measure angle F. What information I have? I have the adjacent and I have the opposite. So adjacent, opposite, we can use tan inverse. So tan inverse, opposite over adjacent, 2.1 over 5.3. So tan inverse shift tan 2.1 over 5.3 to get the answer is approximately is equal to what? To 22. Now I need to find the measure of angle D. So I can say 180 minus 22, 90, or direct we can say it's equal 90 minus 22 to get the answer as 268, I think. So 90 minus 22, so it's equal to what? Is equal to 68. So here, so always remember that in the right triangle, the trigonometric ratio, sine, cosine, tan, sine opposite over hypotenuse, cosine is equal adjacent over the hypotenuse, tan is equal to what? Is equal opposite over adjacent. These are three relations. We can use them for triangle, right triangle, to find what? To find the unknown sides, the measure of the unknown sides, or we can use sine inverse, tan inverse, cosine inverse to find the measure of the angle, of the same angle. So please, this is, of course, it's very important. Study the lesson, solve the questions, and do all the practice. Good luck.